Before to start exercise 5.2, first of all we will study some properties or some laws. The first law is commutative law. For commutative law, we have two numbers or two sets, and one sign will be used in this law. For example, let us suppose we have two sets A and B, then A union B is equal to B union A. This is called commutative property or commutative law with respect to union. If we put sign of intersection like this, A intersection B is equal to B intersection A, so this is called commutative law or commutative property with respect to intersection. If we have two numbers small a and small b, then a plus b is equal to b plus a. This is called commutative law with respect to addition. A into b is equal to b into a. This is called commutative law with respect to multiplication. Now moving to another term on another property which is called associative property. Remember that students, for associative property we have three sets or three elements and single operation sign will be used like this. A union in bracket B union C is equal to A union B union C. This is called associative property with respect to union. For intersection, A intersection bracket B intersection C is equal to bracket A intersection B and intersection C. This is called associative property with respect to intersection. If we have three numbers small a, small b and small c, then we can write a plus b in bracket b plus c is equal to a plus b plus c. This is called associative law with respect to addition. If we multiply these numbers like this, a in bracket b into c is equal to ab into c. This is called associative law with respect to multiplication. Now moving to another term which is called distributive law. For distributive law we have three sets or three numbers and two operation or two symbols are used in this like this. A union in bracket B intersection C is equal to A union B intersection A union C. This is called distributive law with respect to union over intersection. If we can write A intersection bracket B union A is equal to A intersection B union A intersection B. This is called distributive law with respect to intersection or union. If three numbers are given like this, A in bracket B plus C is equal to AB plus AC. This is called distributive law with respect to multiplication over addition. Now De Morgan laws. If we have universal U is a universal set and A, B are two subset of universal set, then the De Morgan law can be written as first law. A union B whole complement is equal to A complement intersection B complement. Then second law, A union B whole complement is equal to A complement union B complement. Now moving to exercise 5.2, question number 1. Verify commutative property of union and intersection for the following sets. The part number first and solution. First of all, data. Let us suppose set A is given which is equal to 1, 2, 3 up to 12 and set B is given which is 2, 4, 5, 8, 10 and 12. Now to verify commutative law or commutative property of union. Commutative property of union can be written as A union B is equal to B union A. First of all, we simplify the left hand side, then the right hand side. Now the left hand side is A union B, putting the value of set A and then set B. Now taking union of these two sets which is equal to 1, 2, 3 up to 12. This is our answer number 1. Now, right hand side, which is B union A. Now putting the value of set B and set A like this. Set B, which is equal to 2, 4, 5, 8, 10, 12, and set A, which is 1, 2, 3 up to 12. Now taking union of these two sets, which is equal to 1, 2, 3 up to 12, this is called equation number 2. A is the answer of equation 1 and 2 are same. So from equation 1 and 2 we have left hand side is equal to right hand side, or A union B is equal to B union A. Now, commutative property of intersection. A intersection B is equal to B intersection A. Now, first of all, left hand side, which is A intersection B. Now, putting the value of set A, which is 1, 2, 3 up to 12, and then set B, which is 2, 4, 5, 8, 10, 12. Now, the common elements, which are 2, 4, 5, 8, 10, and 12. Now, the right hand side, which is B intersection A. Putting set B, which is 4, 2, 4, 5, 8, 10, 12, and then intersection, and then set A, which is 1, 2, 3, 4 up to 12. Now taking intersection of these two sets, which is the common element, and the common elements are 2, 4, 5, 8, 10, and 12. This is called equation number 4. Is the answer from equation number 3 and 4 are same. So from equation 3 and 4 we have left hand side is equal to right hand side, or A intersection B is equal to B intersection A. Now moving towards part number 2, solution. Set A is given, which is natural number, and we know natural number are starting from 1, 2 up to so on. Then set B is given, which is x, such that x belong to n, and x is an even integer. So we can write even integers. Set B is equal to 2, 4, 6 up to so on. Now commutative property of union, which is A union B is equal to B union A. Now putting the value of set A, then union, then set B is equal to as it is, then the value of set B, union as it is, then value of A. Now taking union of these two sets, which is 1, 2, 3 up to so on, and taking union on right hand side, which is equal to 1, 2, 3, 4 up to so on, is the left hand side and right hand side are equal, hence it is proved. And commutative property of intersection, A intersection B is equal to B intersection A. Now putting the value of set A, then intersection, then set B is equal to B set, and then intersection as it is, and then set A. Now taking intersection, intersection means taking common element between the sets. So the common element between these two sets is 2, 4, 6 up to so on, and in these two sets is 2, 4, 6, as the left hand side and right hand side are equal, so it is proved. Now question number 2, verify associative property of union and intersection for the following sets. Part number 1, solution and given data. 3 sets are given. Set A is equal to small a, b, c, d up to z. Set B is equal to a, e, i, o, u, and set C is given, which is a, d, i, l, m, n, o. Now associative property of union, which is A union in bracket B union C is equal to A union B bracket union C. First of all, we will verify left hand side. So the left hand side is A union bracket B intersection C. Now putting the value of set A, B and C like this. First of all, we will simplify the bracket. Taking union between these two sets, which is equal to ADEILMNOU. Now taking union with A, B, C, D up to Z, so the answer is A, B, C, D up to Z. This is called equation number 1. Now taking right hand side, which is A bracket A union B union C. Now putting the value of set A, set B, set C like this. Now first of all we will verify the brackets. So taking the union of these two sets, which is A, B, C up to Z like this, and this set as it is. Now taking union of these two sets, so this is equal to A, B, C, D up to Z. This is called equation number 2. From equation 1 and 2, or comparing equation 1 or 2, we get left hand side is equal to right hand side. Now associative property of intersection, which is equal to A intersection B intersection C is equal to A intersection B bracket intersection C. Now left hand side, A intersection bracket B intersection C. Putting the value of set A, set B and set C like this. First of all we will take intersection between these two sets which are in the brackets. So the intersection between these two sets is A is common in first set and second set, I is common in both sets, and O is common in both sets. So the intersection between these two sets is AIO. Now taking intersection of AIO with this set A, B, C, D up to so on. So the answer is AIO. This is called equation 3. Now right hand side, A bracket A intersection B intersection with C. Putting the sets like this. First of all we will take the intersection between these two sets which are in the brackets. So the answer is AEIOU like this. Now taking intersection between these two sets, so the common element is A, I, O. These three elements are common between these two sets. So this is called equation number 4. As the answer in equation 3 and equation 4 are same, so from equation 3 and 4 we get left hand side is equal to right hand side. The part number second is same as this question number 2, part number first. So the student will solve it itself. Now moving towards question number 3, verify distributive property of union over intersection and intersection over union. Part number 1, solution, the given data. Set A is given which is 0, 1, 2 and set B is given which is 0 and set C is pi which is empty set. Distributive property of union over intersection is as A union in bracket B intersection C is equal to A union with B like this, then intersection, then A union with C like this. Left hand side is equal to A union B intersection C. Now putting the value of these three sets like this. First of all we will simplify the bracket, taking intersection with these two sets, so the answer is empty set. Now taking union of these two sets which is equal to 0, 1, 2, this is called answer number 1. Now right hand side is A union B intersection A union C. Now the putting the value of set A union, then set B, then intersection, then set A and then set C. First of all we will simplify these two brackets. So we will take the union of these two sets which is equal to 0, 1, 2 and then taking union of these two sets which is equal to 0, 1, 2 like this. Now taking intersection between these two sets which is equal to 0, 1, 2, this is called equation number 2. As equation number 1 and equation number 2 are same, so from 1 and 2 we get left hand side is equal to right hand side, or A union in bracket B intersection C is equal to A union B intersection A union C. Now distributive property of intersection over union, which is equal to this. First of all, we will simplify the left hand side. Now putting the value of sets A, B, C like this. First of all, we will simplify this bracket and taking union between these two sets, which is equal to 0. Now taking intersection between these two sets, which is equal to 0. This is called equation number 3. Now right hand side, which is equal to A intersection B union bracket A intersection C. Putting the value of sets like this. First of all, we will simplify this bracket and this bracket. So taking intersection between these two sets, which is equal to, answer is 0 in sets, and taking intersection between these two sets, which is equal to empty set. Now taking union of these two sets, which is equal to 0 in set, answer number 4. From 3 and 4 we have left hand side is equal to right hand side. Now part number second, same is part number, question number 3, part number first, and student will solve it itself. Now question number 4, verify De Morgan laws for the following sets. Solution. Data. Universal set is given which is equal to x such that x belong to n, 1 is less or equal than x, x is less or equal than 20. It is called set builder notation form. The set is represented in the set builder notation form. So this is equal to universal set 1, 2, 3, 4 up to 20. Then set A is given which is equal to 2, 3, 5, 7, 11, 12, 13, 17, and set B is given which is equal to 1, 4, 6, 8, 10, 14, 17, 18. Now, first of all, we will find A complement and B complement. For A complement, this is equal to universal set minus A. So putting their value, universal set as it is, then difference, then set A. Taking difference between these two sets, the answer is 1, 4, 6, 8, 9, 10, 14, 15, 16, 18, 19, and 20. And to find B complement, we will put the value of universal set and then set B, and then we will take the difference between these two sets, which is equal to, so the B complement is equal to 2, 3, 5, 7, 9, 11, 12, 13, 15, 16, 19, 20. Now to find the union between set A and set B, first of all we will find the union set A, first of all set A, then union, then set B. To combine these two sets, so A union B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 17, 18. And then A intersection B. So taking common between these two sets, which is equal to 17. Now De Morgan law. First De Morgan law is A union B whole complement is equal to A complement intersection B complement. First of all, left hand side, which is equal to A union B whole complement. To find out complement, so universal minus A union B. Now putting the value of universal set and A union B from the above data like this. So the answer is 9, 15, 16, 19, 20. This is called equation number 1. Right hand side, which is A complement intersection B complement. Putting the value of A complement B complement like this, and then we will take intersection. So the common element between these two sets is 9 is common between two sets, then 15 is common between two sets, then 16 is common between two sets, then 19 and 20, and 19 and 20 is common between two sets. So left hand side is equal to 9, 15, 16, 19, 20. This is called equation number 2. From 1 and 2 we have A union B whole complement is equal to A complement intersection B complement, or left hand side is equal to right hand side. Now the second law, De Morgan second law, is A intersection B whole complement is equal to A complement union B complement. First of all, left hand side, A intersection B whole complement, which is equal to universal minus A intersection B. So putting the value of universal and A intersection B. So the answer is taking difference between these two sets subtracting 17 from, so 17 cancel with 17 and the answer is 1 2 3 up to 20 except 17. No, right hand side is, which is A complement union B complement. So putting their values, A union A, then A complement, then union, then B complement. Combining these two sets, the answer from equation 3 and 4 are same. So from equation 3 and 4 we have A intersection B whole complement is equal to A complement intersection B complement. The part number second is same as question number 4 part number first. So the student will solve at self this part.